Alrighty. What is going on, everybody? Welcome to Learn to Defend Cyber. My name is Joseph. Today we're going to be going over Try Hack Me's day number 8 room for the advent of cyber. Try Hack Me is a platform where you can learn how to both hack and defend machines. And the advent of cyber is a daily challenge. We've been going through it for about 7 days now. And today it looks like we've got shell codes. We're learning a little bit about shell codes. It's a purple room. So we'll maybe be doing a little bit of a red team and blue team exercise. I went ahead and started the machines because I went and read the little image they give you to tell you what you need. And almost every box was clicked. So I figured it was a little complex today. So we got B-Sec in chat, and we got Rhonda in chat. Welcome. I did add a chat box. I'm not sure if y'all are able to see it. Let's see. Can I throw that on? That would help, maybe. Not sure. I see nothing, B-Sec says. Good, it's working. Oh, nope, there it is. I see it. You must be learning from Jerry. Yeah. Jerry School of AV and OBS. So I had a delay on it. I made it to where the delay was a little too long. Needs to be okay. Let's see, what can I do? Edit this on the fly. Maybe not so much that big, but I can definitely bump up the font a bit. No, that should work. Try now. White on white though. Oh man. Yes, it is. I'll have to make a dedicated section so I can have it be on a nice contrasted background so that even when I click through different windows it doesn't really change it too much. But either way, that's a problem for tomorrow. Throw a little opacity. Okay, that's a good idea actually. Come on. Let's do this, and then let's do this. Beautiful. That work does not look like it. I'm not sure why I don't actually have the option for an opacity like slider. So we'll have to I'll have to mess around with this afterwards. Yeah, absolutely. I'll go ahead and just hide it for now so that it's not distracting people with the opacity problems. It's time to dive into this room. We can I'll work on that stuff behind the scenes. All right. So today we got shell code shell code. And it looks like we have a little bit of a story, as always. If you've been working through the advent of cyber, you will know that I feel like that music got way louder. It did. Alright, if you've been working through the advent of cyber, you would know that every day they give us a little bit of a poem and some context as to the story of the room that we're working in. And today it says, Glitch the hacker, clever yet distrusted, wrote a script with skills finely adjusted, shellcode magic to hit to his home it would send, where secrets of Wareville he'd carefully pen. Butch, a skilled but mistrusted hacker, was prepping for a tech conference. He was eager to share his shellcode script that remotely accessed his home system. As he worked, he noticed Mayor Malware's henchmen lurking nearby. They're wasting their time. I don't have anything they'd want, Glitch chuckled. He didn't realize that hidden in his home was something they desperately sought, a research paper he wrote on Wareville's defenses. A treasure Mayor Malware was eager to obtain. So, the objectives today are to learn, grasp the fundamentals of writing shellcode. We're going to generate some shellcode for reverse shells, and then we're going to use that shellcode with PowerShell. So, a little bit of context. Shellcode is very lightweight, low level meaning machine readable code, used typically either to exploit a vulnerability or, I mean, there's a wide variety of functions it could provide. It interacts with resources a little bit more on your computer, such as your operating system, your hardware. And a reverse shell is, so there's shells and there's reverse shells. A shell is you reaching out to something and interacting with it. And again, you're interacting with it at a lower level. And a reverse shell is where something reaches out to you, and that's how the connection is made. It's the same thing, it's just what direction the connection is established. And we can see that they give us a list of essential terminologies. We have shellcode defined, piece of code developed by malicious actors typically, during exploits like buffer overflows to inject commands into a vulnerable system. Yep. So it gives them more control over a compromised machine, and then it's written in assembly. Assembly is that low-level language I was talking about. Again, low-level meaning that it is more machine-readable than it is human-readable. And low-level languages actually have far more control over the machine than a high-level typically does. We learned a little bit about PowerShell. PowerShell is the scripting language built into Windows. So you have your command prompt and you have PowerShell. PowerShell is far more powerful. It's used in a lot of power user behavior, a lot of automation, and threat actor behaviors because it has a lot of access to the Windows API, the Windows OS. You can do just about anything on a Windows machine with PowerShell. Windows Defender. Windows Defender is the built-in AV. It used to be a joke. Everybody joked that Windows Defender was easy to roll over and how it missed everything. But they've improved it a lot as of 2024. It's still not like, I wouldn't call it the best, but if you pay for Windows Defender ATP, which is Advanced Threat Protection, it's actually pretty good. It's one of the better AVs out there, and ATP is also an EDR, I want to say. But it's far less of a joke than it used to be. They made it harder to disable. They made it harder. They made it better at detecting malicious behavior. They definitely gave it a lot more behavior-based detecting abilities than it used to have. I think it used to just all be hash-based, which is when you have a malicious piece of code that is known and you take a file hash of it, which is basically like a fingerprint, and if it sees that fingerprint, then it freaks out. But other than that, it didn't do much before, but they did actually improve upon it a lot. So there are still ways to get around Defender by obfuscating code. We talked a little bit about obfuscating code yesterday. I want to say that was yesterday. To disguise malicious content, making it harder for it to detect it. Reflective injections, where code is loaded directly into memory. Avoiding detection by signature-based defenses. Yep. So that's where you would need a more behavior-based detection tool. And then we have the Windows API. So an API is just an application programming interface. It allows you to interact with the, I guess, the inner workings, so to say, if we're going to try and break this down into an easier way of talking about it. So you would have your normal command line, right? Your command line, you can do a lot, but if you start interacting with the API, you're actually interacting with the functions of a program. So you have far more control over that program. we're talking about, it seems that we're going to be talking about some API functions here, commonly used by threat actors. You will see this if they're going to be loading something into memory. When you load something into memory, it's not stored on a computer, it is stored in the RAM, and RAM is volatile, so it doesn't actually reside there forever. If you were to restart the computer, funnily enough, you would actually lose that, you would lose the code running in memory. So what you would have to do as a threat actor, if you wanted to persist, you would have to have some form of persistence mechanism that called that code that you're going to run into memory. So, for instance, if I wanted every time a computer to start up and have my code run in memory so that it wasn't detected by either EDRs or AVs, depending on whatever you're trying to get around, right? I would probably have a script stored in the startup file, the startup folder, so that every time the computer came on, it would run code that ran my code in memory. It would compile it, create the threads, etc. So you can see we have virtual allocation here, create thread, and wait for single object. We'll talk a little bit more about that later. And then we can access the API through PowerShell, right? So PowerShell, as I said, it is a very, very powerful tool, and it can interact with the Windows API. Funnily enough, if you ever start digging into the logs of a Windows machine, PowerShell logging isn't actually that verbose by default, but with Sysmon you can see a lot more. Windows is really just a lot of API calls happening that they slapped a GUI on top of, and you can say that for most operating systems. And then we talk about reverse shells. I did talk about that a little bit earlier. It's where the shell of the machine that you are trying to hack or access calls out to you instead of you calling out to it. Reverse shells are very handy because a lot of firewalls may block malicious traffic coming in, but if they're not configured correctly, they may not look at traffic going out. So if you have, for instance, port 80 traffic coming in blocked, you may not actually have port 80 traffic blocked going out, which means that if I had a port 80 shell that was on your machine that I managed to have launched and call out to me, it's going to go through, whereas if I tried to call to that machine, it would get blocked. So we're going to talk about generating shellcode. It looks like we're using MSF Venom. So MSF Venom is the Metasploit framework tool used for generating malware, and they give us a script here. We can break down what that script does. Of course, we're gonna have to. So MSF Venom is the name of the tool. It is loading the module Windows 64 shell reverse TCP. So it's loading a module that is pre-written. MSF Venom and Metasploit framework in general does come with a lot of pre-written modules that have pre-baked attacks, pre-baked malware, and so it's loading the reverse shell, and it's loading a TCP reverse shell, so it's going to go over the TCP protocol instead of UDP. Those are your two main networking protocols. If you ever have to take the Network Plus or the CCNA, really that's what they focus on, TCP and UDP. The L host is the value for listening host, so that would be our attack box. Because this is a reverse shell, we are listening, waiting for this connection to come in, and then the listening port of 1111 is just a random port. You could use almost any port that isn't already allocated or commonly used, but in this example we're using 1111, and then TAC F, I want to say, is putting it out to a PowerShell readable file. Yep, okay, so it specifies format. F is for format, and we're formatting it to PowerShell. And PowerShell, again, as we talked about, is that Windows shell tool. So we want it to be able to be read because we're going to be running it on a Windows machine. We're going to write it on a Linux machine, but we want it to be able to be read on a Windows machine. So let's go into our terminal here. I can blow this up a good bit to read. actually get a terminal. Oh. On Firefox on accident. So we have our command that we're going to run here. Go ahead and hit enter. Takes a moment because it's going to have to generate the code. We can keep reading while it does that. So we can talk about the output. We see what the output's going to look like right here. Oh, I never put my IP address in there. That is my fault. So we talked about earlier about having to change that attack box IP to our IP. I never did that. So I gotta go back and rewrite this part. Our IP, you can see right here, is 10.10.16.148. 10.10.16.148. I put a dot between the 10 and 16. Try this again. It should work this time. But this is the output that we should expect from Metasploit framework doing its thing. We can talk about the payload size. That's how big it is in bytes. But once it is converted to a PowerShell readable format, it is 2,259 bytes. And this is the PowerShell readable hex array. So this is a hex array. You can tell because it has both decimals and letters. That's how I typically identify hex. And this is machine readable, but not human readable. They could theoretically write it in binary, but for sake of size, you can convert it to hex. And it makes everything a lot cleaner. The actual shell code in the output is the hex encoded byte array, which starts with 0x, and we talked about this. So it starts with those values and so on. The hexadecimal number represents the instructions set on the target machine. Computers understand it. Obviously, we can't understand it. I'm sure you could probably translate it somehow, but it would take a lot of time. And then we can execute the shell code by loading it into memory, and this looks like a big old PowerShell script to do exactly that. So you have VRT allocate, which starts allocating your memory. We're waiting for the system. We import a kernel DLL. Then we allocate our threads. A thread is just a single stream of instructions. And then we're going to, looks like we allocate that memory down here. So this is where we would have the shell code come in. And then it gets put into memory randomly by the operating system. It's going to determine where it wants to put it. And then we'll have our references that we need to be able to run the code. You don't have to understand all of this, by the way. You'll never have to understand all this. Unless you want to write your own PowerShell script that does this, then you'll have to understand it. But most of the time you can copy-paste pre-cooked commands like that. But they are more likely to get detected because they are known to be malicious. Or they may not be detected because other applications may do something similar to this. So depending on what you're using, you can get away with it. We have a little bit of an explanation down here, talking about kind of what we talked about already. Creates the thread, allocates the memory, and then we pause until a specific thread finishes its task. And in this instance, we're waiting that we're making sure that the shell code has completed its execution. See, we got our shell code here. I can probably zoom out a little bit, just so we can copy this a little easier. Want to just do not want to zoom out the shell. Okay, that's fine. We'll have to copy paste this. So we'll take this, Control-Shift-C to copy. And then, what do they want us to do with it? I know they want us to put it in that PowerShell code. Where we have that placeholder byte array. What's going on, haircut fish? Stopping in while getting home from church and getting lunch. I hope church went well, and I hope lunch is good. I actually ate before coming on stream. That's why I was a couple minutes late, because I was cleaning up. So they're breaking down more about what happens with the shellcode here. Time for some action. Okay, so it sounds like we're going to go ahead and execute this shellcode. We have NC NVLP 11111. Sure, that was too many ones, but that's the port that we were listing on. We set that in our shellcode. So NVLP. Netcat is a networking tool used to write commands or receive commands from a remote machine, and it's just a way of interacting with machines normally, or over the network, sorry. So we'll go ahead and get Netcat listening on our Linux machine here. This is our attacker's machine, so we want to be listening because this is a remote shell, so it's going to call back to us, and we want to be listening on the correct port, right? So NVLP, these are the different flags. N means no DNS lookup, V is verbose, L sets it to listening mode, and P determines the port. So we're listening on port 1111. And now we have to actually run. We have to first edit the PowerShell code they give us. So let's go ahead and do that. We'll bring up Sublime. Make this bigger so it's easier to read. And we take this PowerShell we were given earlier, copy it, go ahead and paste it over here. Can I make this bigger for y'all to read it easier? Absolutely. And we want to take that output we got earlier, this hexadecimal that we were given, make sure we copy it. Control-Shift-C. Come over here and replace this with that bytecode. Get rid of that blank line. And this is our full payload to allocate the memory, run our shell in the memory so that it's less, or it's harder to detect. And then we'll be able to start moving from there. So they want us to go ahead and go over to the Windows VM that they give us. No, I will not be running this as an administrator. I will be running this normally, because I don't know the admin password for this. I'm sure they gave it to us somewhere. But we can do this as a normal user as well. So if we do this right, we're going to want to paste it bit by bit so it's actually harder for Defender to detect us. If we were to paste this all at once, it would probably stop us. And I'm actually willing to find out. I'm willing to call Defender's bluff to see if it stops us. Let's paste all of it at once and see what happens. So here's our full payload. Okay, we hit enter. Okay, it did catch us. This script contains malicious content and has been blocked by your antivirus software. So it did stop us. So what we're going to do to get around that is we want to actually just load this one bit at a time. We can do all of our memory allocation and our thread allocation because that's a pretty normal, right? That's a normal process. You see applications doing that all the time. And now that we have it loaded, we can copy this. We'll copy our shellcode. Run that shellcode. And then add the last little bit. I'm wondering if I had to copy that shellcode and put it with there as well. No, it looks like I did that the right way. I can make this a little bit bigger for us so you can see what's going on. It won't let me. Oh, looks like Defender found some threats. I'm sure that was probably when we ran that code and it detected that. I'm trying to blow this up a little bit, but the machine is lagging on us. Okay, that's a little too big. By the way, if you're ever wanting to blow up your output for readability in PowerShell, they don't have like a view or an options thing. You actually just right click right at the top and that's where you'll get your properties. And then there's keyboard shortcuts that aren't really working. And we can see that it's just waiting. It's waiting for anything. So let's go back here and see if we got our shell. We're in. We got our netcat shell. You can see here that the connection was received. And we are on a server, and we can start issuing commands, and we might be able to see that reflected. No, we don't see anything reflected. So it's completely silent. To be an elite hacker, I heard you have to use port 1337. Absolutely. If you're not using port 1337, you're not doing it right. So that is the directory that we landed in. What do they want us to do from here? Now the glitch must act. No time to delay to fix the shellcode and keep foes at bay. He tweaks and he codes to set the wrongs right, protecting his secrets with all of his might. Let's troubleshoot the issue with part of this task. Glitch has realized he's no longer receiving incoming connections from his home base. Mayor Malware's minion seems to have tampered with his shellcode and updated both the IP and the port, preventing Glitch from connecting. So he needs to change the IP. It's going to be the same IP, our attack box, but we need to actually be listening on 4444 instead of 1111. So we can Control C to get out of netcat, and we can run that MSF Venom command again. By the way, hitting up on your up key allows you to go to commands that you've run before. And we're going to actually need to come over here and open a new PowerShell window, because we killed that process, and we are going to change the port to 4444. Start listening, or rather get this code generated so we can get the new byte code. This will be our new byte code. We need to copy this and replace it in that placeholder area that we had. Control-Shift-C. Here. Control-Shift-V. That is our new byte code. And we need to do what we did again, or did earlier again, right? We need to come here and add it step by step. So we're going to go Control-Shift-C and Control-V. Start that process, then we can paste our bytecode in, and PowerShell will interpret us just as it did earlier. Control-V to paste it in. And then Control-Shift-C. You know, rinse and repeat the process. Same thing we did earlier. Alright. And now, we need to start our netcat process again, NVLP, same flags, but on port 444 instead. I may need to do the PowerShell process because I think I got the actual... It should connect, but I may need to redo this because I actually established the reverse connection before. Yes, okay, I need to redo this. So, start this process. Let's get netcat going before... We'll get it listening before we actually establish the remote shell. So, let's go ahead and do this. No need to explain it a third time. All of this bytecode. Okay, and now back here on our terminal, should have received a connection. Perfect. So now that we're here, we want to find the contents of user glitch desktop flag. So we can go ahead and just copy this command. Type is essentially just cat. We talked about the cat command yesterday and a couple times before, and we get our flag. AOC got my access back 007. Control Shift C to paste it or copy it, and then we can Control V it, boom, submit. And that is today's room done, day 8. I think it was a good room. Definitely explains the concept of shell codes, reverse shells a little bit, talks about how communication is going to happen. Now we can talk about real world application a little bit, right? So establishing a reverse shell like that is fine. We had a process where we took that PowerShell code and we had that, we just pasted it ourselves, right? Now, in the real world, we wouldn't be on our attacking machine and then be able to just go to a machine and paste PowerShell code in. We would have to probably use what is known as a dropper or some form of staged payload where we create it to run that PowerShell for us. So you would have to do that initial infection, get that on there, run that PowerShell. I kind of talked about this earlier, right? And we'd want to run that PowerShell to get that code in memory, and then we would be able to do what we did. So we would have to have a first stage. This shell would be a second stage. And we talked about how it's actually harder to detect malicious activity happening in memory. There are definitely EDRs and different AVs that can do it, but how we would write detections, or how we would detect this, is by detecting that initial process, the initial process of getting that code ran in memory. So that's where we would start building our detections, and that's where we'd want to focus. And of course, you would have behavior-based detections where we could see that we were beaconing out on a weird port and watch for malicious traffic there. There's quite a few ways that we can stop this in the process before it becomes a problem. So BSEC says no, just send some Robux out to the kids and get some reverse shells. That's a real thing. A lot of your free Robux, free V-Bucks, you know, typical scams are data stealers, but there are definitely still Well, there's also crypto steals, but there's definitely still reverse shells every so often, and they do work. So I think we're going to go ahead and round it out for the day. Thank you all for tuning in. I will see you all tomorrow at 5 p.m. Monday, December 9th at 5 p.m. for day 9. I hear it's going to be a fun one. Thank you for tuning in. I will see you tomorrow.